So we just came up with an equation for the thermal efficiency of the Otto cycle. And we said that it could be expressed in a compact manner in terms of the compression ratio and the ratio of specific heats. Now, typical spark ignition engines sometimes you'll see that referred to as SI for spark ignition. They have compression ratios that range from about 6 to 12. And if you look up information on an engine, sometimes you'll see them expressing it in the following manner: 6 to 1 and 12 to 1. So if we're looking at a ratio of specific heats for air of 1.4, we can find that with the 6 to 1 compression ratio, R is equal to 6, and then the thermal efficiency for an Otto cycle would be about 51%. And if we have a 12 to 1 compression ratio, the thermal efficiency for the Otto cycle, now remember that this is an ideal Otto cycle, is 0.6299, which sounds great. I mean, we're talking 51 to 62, 63%. In reality, however, nature comes in and plays some tricks on us and prevents us from being able to have this idealized scenario. And in reality, real SI engines have lower thermal efficiencies So typically in reality we're somewhere between 20% to 30% depending upon the design, and this would be for Otto. It'd be more in that kind of range is what you would normally find with an engine. So what we're going to do now, let's take a listen to a real-world engine that operates under the Otto cycle, and I'm sure many of you have heard this before, and so consequently it may not be that novel. However, it'll be interesting to compare this to the diesel cycle or the compression ignition when we hear that in the next little lecture component. So let's take a listen to the Otto cycle now. Otto cycle, that's internal combustion spark ignition engine. So let's listen to it, and that will give you an indication. So that beautiful piece of engineering that you just heard was my BMW. It's a 525i Touring, and it has an inline 6 engine. And that particular car is a little bit of vintage now. It's from 1991, I believe, is the year on it. The one thing that we can say about any kind of engine, when we look at our thermal efficiency, is that you naturally think that if you go to higher compression ratios, you will have higher thermal efficiency. And I should make a comment about that. So a theory would tell us that the higher the compression ratio is, the higher the thermal efficiency is. However, what happens is we start running into some problems. As you increase the compression ratio, you start encountering what is called combustion knock. And what this is, it's where you start to have combustion due to the high temperatures and pressures before the spark even goes off. Sometimes called spontaneous combustion. Or auto ignition. And the reason why we call it knock is because you'll hear a sharp metallic knock in the engine if you listen to it. Luckily, the 525i that we listened to a moment ago is operating properly, and so consequently you did not hear any knock in the engine. All you heard was fine engineering, German engineering coming through and talking to us. So anyways, that concludes our cover of the Otto cycle. What we'll do next is we'll venture into the next form of internal combustion engine that we will look at. And this is one of compression ignition, not spark ignition like we just looked at.